Welcome everyone. Today I'm going to talk with Dr. Brady Carter, our lead scientist for water activity, a bit about over test time in water activity testing. Welcome Brady, and thank you that you took your time to talk with me again.
Yes, of course.
We have heard that test time for water activity is quite a controversial topic sometimes because sometimes it takes a really long time in the device to measure water activity. There's also like some different advertising from different producers. So to start off, what dictates the test time of a sample for water activity?
Yes. So with water activity, what we're dealing with is an equilibrium measurement. We need to find out what the equilibrium vapor pressure is over a sample because that's related to the energy of the water in the sample. And that's the way that we figure that out. And in order to do that, we have to have a state of equilibrium where that vapor equilibrium has been achieved. And then the vapor pressure above it does reflect what the energy of the water is in the sample. And that takes time. That takes time for those water molecules to escape into the vapor phase. And different types of products will take different amounts of time. So if you have hydrophobic material, water has to try and move past that, and it doesn't want to, so it extends the test time. So it really depends on what type of product that you're reading that determines the test time.
So if I got that right, it's not the device which dictates the test time. It's more about like the sample and how long it takes to get into the vapor phase till you can measure actually the water activity in the chamber, right?
Right.
So why is there like this discussion a lot? Which device is the fastest one, or what do you think about it?
Yeah, so there's and obviously there's reasons to try and say that the test is fast and that maybe it's a 5-minute test and that all is can be manipulated based on what type of sample you're reading, and a lot of times those reports are coming from readings on standards, which are very simple solutions. So it also comes down to what you use to determine the end of test. So equilibrium, the way we determine equilibrium is through a static state, a static condition, because water molecules are in constant flux. And so what we're looking for is a rate of change, and that rate of change to fall below a certain level. And by rate of change, I mean the change in water activity. So it's going to take a water activity reading and compare it to the one previous. And it's looking for a certain difference that would indicate static conditions. The problem is that the different instruments that are out there are most likely using different requirements for that end of test. And if you use less stringent requirements, it will give you results faster, but the consequence could be inaccurate readings.
So what you're saying is it depends how fast the device measures, for one on the sample, and on the other side it depends on the settings on the device. If you the stability settings you mentioned, if they are like very stringent, so you need a longer time till it says it reached equilibrium, or if you have less stringent settings which say after 1 minute say, oh yeah, now the equilibrium is reached. How does the stability settings influence your testing? Or is the stability setting like a really important factor, or can you like, isn't it a problem if you change it to a less stringent setting?
Yeah, so it is important. It does influence test time, but it also, as I said, influences your results and the accuracy of those results. In fact, it's so important that within the ISO method for water activity, that's ISO 18787, it actually dictates in that method what those requirements will be for end of test. So it sets them ahead of time so there's not any kind of misunderstanding or variation in what end of test settings are used. And often if you use the ISO 18787 setting in one type of instrument using one type of sensor, and you use it in another instrument using a different type of sensor, they'll give the test time will be very similar because you're using the same end of test requirements. And so it has a big impact on those results. And if you set it to a setting that's not stringent and you get those results fast, what can happen is that if you actually set it to a stringent setting and you did that and you compared the results, you may be off by as much as 0.02 water activity. That could be the difference between having growth, microbial growth, and not having microbial growth.
Yeah. And as we heard from you before, that can lead to recalls and to a lot of costs for a company.
Yeah.
So in conclusion, what we heard now from Brady is that test time is mostly dictated by how long it takes the sample to get into the vapor phase, which is different for each sample, and the test time is mostly dictated by that and by the stability settings you use on the device. So if you compare devices, you should also compare what stability settings they're using.
Right.
That's correct, right?
Absolutely.
So yeah, I mean, that was very interesting, Brady. Thank you very much again
Yes,
for joining
of
us
course.
today. And yeah, let's see you in the next video.